Welcome to this step-by-step tutorial on how to make a tasks application on iOS. In this tutorial we aim to show you the fundamentals of programming on iOS by showing you all the main things you'll need to do when building your own application. This tutorial will be split into 4 parts. The first part we will set up our tab bars, navigation controllers, the brain for the application and a few other little bits. In the second part of the tutorial we'll set up our table views as well as configuring the cells. In the third part of the tutorial we'll create an add screen so that you can add new tasks. And in a fourth part of this tutorial we'll look at persisting the data between application launches. So let's dive right in. Launch Xcode and click Create a New Project. We're going to choose the empty application template within the application part of iOS. This gives us a base to build exactly what we want with no templated files. Select this and choose Next. For product name, I suggest you choose Tasker or Tasks. I'm going to go with Tasks. Your company identifier is a way to uniquely identify this application if you publish it to the App Store. Your class prefix is a string that will be appended to every file you create. Leave device family as iPhone for now. We're not going to use core data, we are going to use automatic reference counter. This allows us to avoid having to type release, retain, auto-release, alloc and all other memory management situations. And we're going to avoid unit testing for now. Choose Next and save them in a folder that you can access. Then click Create. Xcode has now created a new project for us. Go ahead and maximise so you have the maximum screen real estate. At the start we're given an application delegate that sets up a window. We're going to change this slightly. Go to File, New File, and we're going to add, under User Interface, a Storyboard. Device family will leave as iPhone for now, and then click Next and give it a name. I'm calling mine Main Storyboard. Then click Create. A storyboard is a way to lay out your entire application's user interface. We'll be making use of this heavily to avoid having to code huge amounts of code. To tell our application to use this storyboard, it's as simple as going to your project and in the main storyboard drop down, select that main storyboard file you just created. Go back to your appdelegate.m file and remove all lines referencing window apart from make, key and visible. Get rid of lines 17, 18 and 19. This will be handled for us by our storyboard. The next thing we need to do is set up a tab bar. This application will have 2 tabs, each with a navigation controller within, each holding a table view. Go ahead and drag out a tab bar controller onto your storyboard. You'll notice it sets the tab bar controller as the initial view controller using this arrow. That tells the application this is the first thing to show when you click Run. For now, get rid of the 2 view controllers. We don't need these. Drag out a navigation controller and another navigation controller. Control drag from your tab bar controller to your navigation controller and select view controller's relationship. This tells it that one of the tabs should go to this navigation controller. Do the same again for your other navigation controller. We now have 2 tabs, each pointing to a navigation controller. One tab will be for handling all the tasks, and the other tab will show a summary of your activity. Let's name these appropriately now. Select the first tab, change the title in the inspector to Tasks. Do the same with the second tab, but this time Activity. These root view controllers are the first view that will be shown in the navigation controller. These are standard view controllers right now. We want table views. So we want to remove each root view controller and drag on a table view controller and another table view controller. Then control drag from navigation controller to your table view and select root view controller. Do the same again for your other navigation control. We now have two navigation controllers within a tab bar controller, each containing a table view without writing a single line of code. Let's make it look a bit cleaner by selecting the navigation controller, then selecting the navigation bar within, and let's change style to black opaque on both. Finally, double click inside the navigation bar on your table view controller and type all tasks. On the other, type all activity. That's it. Save your storyboard and click run. The iOS simulator will launch, and there we have our tab bar with navigation controllers and table views within each. The next part in this part of the tutorial is to build our tasks brain. Let's do that now. Go to File, New File, Cocoa Touch Objective-C class. Let's name this IC, our task prefix, our class prefix, tasks brain. Leave subclass as NSObject, choose next and click create. We now have two new files, ictasksbrain.h and .m. In our .h file, we are going to define our public API. The tasks brain will be a singleton class. In other words, there will only ever be one instance of this class in our entire application. This will be accessed through a class method called main_brain. Let's implement this now. In your .m file for your implementation, we're going to create a method that returns an ICTasksBrain. It's called main_brain, and this needs to be synchronized with self. This is a way to ensure that this is only performed on one thread once. We're going to define a static variable up at the top of this file that is our main_brain object and instantiate it to nil at first. In this method, we check to see if main_brain object has any value in it, and if not, we instantiate a new one. Out with our synchronized statement, we return our main_brain object. This ensures we only ever use one instance of this class. At the moment, this class doesn't do much, but before we can code functionality, we're going to need a class that represents one task in our program. Again, go to File, New File, Objective-C class. Name this ICTask. Subclass of NSObject, choose next, and then create. ICTask is going to have three properties: a title, a description, and a priority. Let's do title and description first. We type @property non-atomic strong. Non-atomic tells the compiler this property is not thread safe, and strong tells the compiler to keep hold of a reference to this until we lose a reference to ourselves. This is going to be an NS string, and we'll call it task title. Again, same attributes and same type for task description. Let's go ahead and implement these. Implementation is nice and simple. Task title, link it to the instance variable underscore task title that Objective-C will create automatically for us. Again, we do the same thing here. That's it. That's all there is to the getter and setter for our properties task title and task description. What about priority? Well, it's going to be a number and we'll call it task priority. Seeing as it's not an object, we don't need to tell it to keep a strong reference. Let's synthesize our task priority. Again, with the same technique. It would be a bit messy in our code to have task.taskPriority equals 0, 1, 2. So let's create an easier way to do this. We're going to use a C function type def enum, and we'll create IC task priority. We'll then have an IC task priority low that is equal to 0, medium, and high. This creates three constants, IC task priority low, medium and high, with the values 0, 1 and 2. This allows us to set our task priority without needing to use explicit numbers. Let's change our type to IC task priority so that it only accepts this type. That's it for our task class for now. We'll come back to this when we look at persisting our data. Back in our tasksbrain.h, we're going to create a few methods that you'll need to be able to access throughout our application. This class is going to be responsible for handling all our data and makes persistent data much easier. It will also be responsible for updating our activity feed whenever we add or remove a task. Let's create a method that adds a task with one parameter in the form IC task. We need to import our task class as shown here. We also need to be able to complete a task. We need to be returned an array of all activity and we need an array of all tasks with a certain priority. Let's explain these a little further. Add task will add a new task object to our internal data storage. Complete task will remove a task from our internal data storage. All activity will return an array of our internal activity storage. And all tasks will return a filtered array depending on the priority you pass as an argument. Let's implement a couple of these now. Go to your .m file. We're going to add some private API that is not accessible out with the class. We do this by at the top of the file defining a new interface with the same class name IC tasks brain, open and close parentheses. This means that we're going to add stuff to the existing class. This is an Objective-C category. We're going to create a property, non-atomic and strong, an NS mutable array, and this is going to be our tasks. We'll do the same again for activity. We're going to add one other method in here, add activity item, and a string is a parameter. In our implementation, we need to synthesize our tasks an activity. We're going to use lazy instantiation here. That means that if you request main brain tasks and there's nothing in tasks, it will instantiate a new array for us. We do this by saying if the instance variable is empty, set it equal to ns mutable array alloc init. Then we return our tasks. The @synthesize will automatically generate the setter for us. We'll do the same with activity. We now have a few methods to implement. Let's first add our add task method. This is straightforward. All we have to do is self.tasks add object a task. But if we think about it, this would be a good place to add our hook to add an activity item for adding the new task. Let's do that now too. Self.activity add object. Then we'll create a string. Added task. Let's escape a speech mark. %@ because we're going to place a string in here afterwards. Again and a speech mark. We then pass a task.task title. This line of code could look slightly complicated. Let's read it through. We get our activity array. If it's empty, it's created using our lazy instantiation. We then add an object that's a string that's returned from this method here. We say create a string with format added task open speech mark with a string in the middle close speech mark. The string in the middle will be the title of the task we're adding. That's it, that's all there is to that method. While we're at it, let's do the complete task method. This is just the opposite. Self.tasks remove object a task. Self.activity add object, same thing here, string with format completed task. And that's it. You notice this code here could quite easily be put in our add activity item. Let's do that. Void add activity item, and let's place this line of code in here. Instead of compiling the string here, all we're going to pass is a item. Now, all we have to do is self add activity item and pass our string. That to me is a little bit cleaner. That's all we're going to implement in the tasks brain for now. Come back in part 2, we'll create our table views, our cells, and implement the table views using a couple of new methods in our tasks brain.